All right, so what if I gave you no function and I asked you to graph it based on information I provided you from the first derivative? So the information we're going to use here is information we've been discussing using the first derivative test. We just have to interpret it because it's given to us in a different manner. So here's your example. Sketch the graph of f, the original function, through the point 1, 1, if we know the following. The first derivative at 1 equals 0. The first derivative is positive for x is less than 1. And the first derivative is negative for x is greater than 1. Whoa, okay, so what are they giving us here? Let's start off with easy step. We're going through this point 1, 1, so let's mark our point. So x is 1, y is 1, and we have a point right there. Now, all of this derivative information, we got to do a little bit of understanding to figure out what's going on here. What does it mean if your first derivative equals 0 at a particular point? We've talked about this. This is a critical point, which means we can create a first derivative sign chart for that critical point. And if they give us enough information, maybe we can categorize that point. So our critical point we're going to put on our number line. So x is 1. That's where our first derivative is 0. And it tells us actually the sign of our derivative. For everything less than 1, everything on the left, the first derivative is positive. So I can actually put my sign. They've given us that information. We know that first derivative is positive on the left. The first derivative is negative for x is greater than 1. That's everything to the right. We are negative. What does the sign of the first derivative tell us? It tells us whether we're increasing or decreasing. If the first derivative is positive, we're increasing over that interval. If the first derivative is negative, then we're decreasing over that interval. If we're increasing and then we're decreasing, what does that mean about our critical point? We go up to the point and then we go back down from there. That means this must be a local max. In this case, it's actually the absolute max, assuming they've given us all the relevant information. We're going to assume that in this problem, and we're just going to draw the picture. So we know we're increasing up to our point at x equals 1, which is the point they gave us, 1, 1, and then after that, we're decreasing. Now later on, we're going to talk about the second derivative, and that's going to talk about some other areas that we could clarify on this, but for a basic graph, this is the information that they've given us. They gave us a point. They told us the information that the first derivative is positive, which means our function is increasing, and then our first derivative is negative, so our function is decreasing. And at that point, 1, 1, our first derivative is 0, so that's got to be our local max. There you have it. So, not a difficult problem. Just take it slow, one step at a time. Focus on one detail at a time. In this case, I started with the point. Then go down the list of characteristics that they're giving you and think about what each one means. We've talked about everything, but they're going to present it in a little bit different fashion. That's it. That's how you graph a function based on information from the first derivative.